All right, so we're going to begin our very last section, parts of similar triangles. If two triangles are similar and they both have the altitudes drawn in, remember an altitude goes from a vertex, after she gets back, to the opposite side. And it is perpendicular, so makes a right angle. All right, so that's what we see in these two triangles right here. This segment goes from a vertex down to the opposite side. And where it hits the opposite side, it makes a right angle. So this is an altitude. Same thing with this segment right here. From a vertex down to the opposite side. And it makes a right angle when it hits the opposite side. So this is also an altitude. The corresponding altitudes are proportional to corresponding sides. So I see that one of my altitudes has a length of 4. The other altitude has a length of 6. So I can make a fraction 4 over 6. It says it is proportional to corresponding sides. So that could be these two sides, the 5 and the y. Those would be corresponding sides. So I could make a fraction out of that. 5 over y, small triangle over big triangle. Or we could be looking at these pieces on the bottom down here, the 3 and the x. So 4 over 6 would also be equal to 3 over x. Let's go ahead and solve both of these. Let's solve for x first. So right here, we're going to solve this equation. 3 over x equals 4 over 6. What would I want to do first if I'm going to solve that for x? Take out the x. We're going to multiply both sides by x because it's a denominator. We could have also multiplied by what? Because it's also a denominator. We could have also multiplied by 6, and we're going to need to do that here in just a moment. So I have 3 equals 4x over 6. Then we're going to multiply by the denominator of 6 on both sides. So over on the left, I have 3 times 6, which is 18, equals on the right, I have 4x. And then we divide both sides by 4. And what is 18 divided by 4? Grab a yellow calculator if you need to. What is 18 divided by 4? 4.5. So 4.5 is equal to x. Just didn't have time. It is up in Canvas. All right. Let's also solve the proportion for y. So I'm going to set up this equation. 4 over 6 equals 5 over y. So I'm going to multiply both sides by my denominator of 6. Cancels my denominator on the left, only multiplies to the numerator on the right. So I would have 4 equals 30 over y. Multiply both sides by my denominator of y. That would give me 4y equals 30. And then divide both sides by 4. What is 30 divided by 4? 7.5. Nicely done. Ms. Bolt. He's not here today. You're welcome. All right. So when we have these altitudes, they are proportional to the corresponding sides if my triangles are similar. So I can set up my fractions just like when I'm doing side, 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 or side angle, side proportionality. All right, let's look down at number 2. Another part of a triangle. Now we've got an angle bisector. There are 2 different things that we can look at with angle bisectors. Angle bisectors, corresponding bisectors, are proportional to corresponding sides. So that's literally just like what we were looking at on the altitudes. Same exact thing. My angle bisector would be this right here. It is 4. Here's my other angle bisector on this larger triangle. It is 10. So I could have 4 over 10. That's proportional to my sides. So like 7 and c. So 7 over c is equal to 4 over 10. Or we could be looking at these sides, the 3 and the a. So 4 over 10 is equal to 3 over a. Let's solve those real quick. We're going to solve this one first. 7 over c equals 4 over 10. Multiply both sides by our denominator of c. So I would have 7 equals 4c over 10. Then I'm going to multiply both sides by the denominator of 10. So I would have 70 equals 4c. And then finally, dividing both sides by 4 gives me the value for c. What is 70 divided by 4? 17.5. So c is 17.5. We can do the same kind of thing here for these 2. We can do 4 over 10 equals 3 over a. Multiply both sides by that denominator of 10. Cancels my denominator on the left, only multiplies to the numerator on the right. So that would give me 4 equals 30 over a. Then I would multiply both sides by my denominator of a. Cancels my denominator over on the right, so 4a equals 30. And then divide both sides by 4. And a equals what? 7.5. How are we doing so far? As long as we're matching up these corresponding pieces and making sure that the same triangles end up in the same parts of the fraction, so little triangle on top, big triangle on bottom, or big triangle on top, little triangle on bottom. Stay consistent between those 2. There's something else that we can see happen with an angle bisector, and that's this picture over here. I have an angle bisector right here dividing my triangle into two smaller similar triangles. So we're going to look at this right here, and we're going to compare that to this down here, and we need to match up the corresponding pieces. So my corresponding pieces would be like the 9 and the x. They're on different triangles or on different sides of this angle bisector. So 9 over x equals, and then I'm going to make a fraction out of my other two sides, the side that's being split by the angle bisector, the 3 and the 4. So 9 over x is equal to 3 over 4. And now we can solve this for x. Multiply both sides by x. So I would have 9 equals 3x over 4. Then multiply both sides by that denominator of 4. What is 9 times 4? So I have 36 equals 3x. And then I divide both sides by 3. And x is finally not a decimal on this problem. What is x? 12 is equal to x. Very nice. All right, so we've talked about when I have an altitude in my triangles. We've talked about when we have angle bisectors dividing the triangles. There's one other part of similar triangles that we're going to look at, and that is medians. You good? Okay. Medians. In case you don't remember, a median goes from a vertex to a midpoint. Vertex to a midpoint. So it's going to split the opposite side in half. Yes. I did not write down a definition for the angle bisectors. Angle bisectors just cut our angle in half. Yes. You're welcome. All right. So corresponding medians are proportional to corresponding sides of the triangle. So here I have a median running right through my triangle, and it is 4. Here I have another median running through my triangle, and it is 8. So I can set up a fraction of 4 over 8. 4 over 8 would be equal to, and then I can match up these two corresponding sides, 7 over 14. Or I could look at these not that side. This whole side right here would correspond to this whole side right here. So I know that this little bit is 3. How big would this whole side be then? 6. 3 and 3 would give me 6. Over here, how big is this side? 2x. Yes, we don't know. But we've called this little section x. So that means this section down here that's congruent would be x. So this would be 2x. So I can set up a proportion with 6 over 2x. Yes. I want to look at these two first. What is 4 divided by 8? That's 8 divided by 4. 4 divided by 8. Yeah, it's 1/2 or 0.5. What is 7 divided by 14? 1/2 or 0.5. So those two really did come out to be equal. These are proportional. Why don't we use these two to set up and solve for x right here? So 6 over 2x equals 4 over 8. And now let's solve this. Multiply both sides by our denominator of 2x. Cancels out my denominator over on the left. So on the left I have 6. On the right, the 2x only multiplies to my numerator, so that would give me 8x over 8. Well, what is 8 divided by 8? 1. So my 8's here are going to cancel, and that leaves me with just one x. So 6 equals x. Absolutely lovely. Let's see if we can knock out the bottom of the page and then call it a week. We've talked about all the parts of similar triangles that we need to talk about. So now let's just get in and practice and figure out which of these different situations we're looking at and how to set up and solve for the variable. So looking at part A, I noticed these things right here. What is this showing me there? Congruence. And there's a line that runs in between them, right? What is this line doing to the big angle if I have two little angles that are the same size on either side? It's cutting it in half. So what would we call this thing? It's an angle bisector. My angle bisector is going to cut my triangle into two smaller similar triangles. So I've got this side over here that I'm going to be looking at. And I've got this side over here that I'm going to be looking at. And I have to match up the corresponding pieces from each of those. So what would correspond to x? 40. So we're going to write a fraction with x and 40. Why don't we do x over 40? Equals, what would I use for my other fraction? 14 and 12. Which one has to go on the top, the 12 or the 14? 12 has to go on top because it came from the same triangle or the same half of the triangle that x did. So 12 over 14. Let's multiply both sides by 40. So I would have x equals 40 has to multiply to my numerator. What is 12 times 40? 480 over 14. Does this come out pretty? Nope, that's okay. You should get approximately 34.286, right around there. That's what you should see on your calculator. All right, let's do part B. On part B, it tells me that AB is 22. So this right here is 22. AX is 18. So AX is this right here. What would we call that? I notice it's making a right angle at the bottom. This is an altitude. Right, it says dy is 15 right here. What would we call dy? Yep, dy is also an altitude because it's making a right angle here at y. And it says we need to find ED. So we're going to be looking for this, and what can we call that? We can call that x. That's our unknown. So help me set up my proportions. Give me one fraction that we could use here. 22 over 15. Is that matching up corresponding pieces? Is that matching side to side and altitude to altitude? No, I have to make sure to match up my sides and I have to make sure to match up my altitudes. 22 over x is equal to, and then the other one would have to be 18 over 15, yes. Match up the altitudes, match up the sides. We're going to multiply both sides by x now. So I would have 22 equals 18x over 15. Then I'm going to multiply both sides by 15. What is 22 times 15? 330 equals 18x. And then the last thing I need to do is to divide both sides by 18. Does it come out nice and whole numbery? No, that's okay. What did we get? 18.3 repeating is equal to x. Nicely done.
So altitudes and angle bisector, they both split the triangle one.
So altitudes, angle bisectors, and medians all split our triangle. The altitude, the way it splits the triangle, it's going to make a right angle with the opposite side. So it's going to turn it into two little right triangles. The angle bisector cuts the angle in half, and it's going to hit somewhere on the opposite side, not any particular place. The median is going to cut the angle, but not necessarily in half, but it hits the opposite side at the halfway point. So we're either cutting our angle in half, we're cutting our side in half, or we're making right angles. You're welcome. Right, the homework that you guys picked up on your way in the door, that is going to be due on Wednesday next week, as I already mentioned. We don't have school on Monday. On Tuesday, we will do the 3 examples that are on page 16, and then you guys will have the remaining class time to work on the homework that's due on Wednesday. That way you'll have time to ask questions about anything you might be confused about still. Wednesday, we will grade that homework and take your skills check. You will also receive the review for the test on Wednesday. Thursday, I'll take any questions you guys have off of that test review, and then Friday will be your Module 8 test.